times and don't realize that you're going in the wrong direction. I thought, well, it's very nice to have all these mounting holes, but I've got these little relays, and they're designed for printed circuit mount that they don't fit 10-page spacing grid like the prototyping board I have. But I've learned that you can mount them sitting up and attach wires, and I'm working with stuff I got lying around. I got all these standoffs and I'm doing this, but I somewhere along the line I'm thinking, you know, I've got to put these on a board and then I can mount the board on here. And I was looking at it and looking at it. Why did I do this? The spacing will be a little different and it'll occupy a little more room, but I should be mounting this stuff right on here. Like I said, you get going in a certain direction and pretty soon you deviated from where you were headed and then you realize there was a better way. I put this center support here to make sure if this thing bounced around that this board wouldn't crack. But within a week, this is all going to be dismantled and remounted on this. Like I say, you get something in your mind and then forget that there's another way to go. But these are, by the way, these are relays scavenged out of these uninterruptible power supplies, these emergency power supplies that you can use with your computers when the power goes out. They keep running. These handle the contacts on these little relays. You might be surprised at the rating. They say they're good for 10 amps at 28 volts. So they'll handle the motor currents for this guy. When you buy this, the motors are, the two right side motors and the two left side motors are wired in parallel. And I don't know any reason why you'd want to run these two any different than both going forward, both going back. So, but if I had a current issue, I could separate them and have each one driven from a separate source to handle each handle a lighter load. Anyway, and $175 for this thing, and it's sturdy, and a nice little pocket in here for batteries and whatever. So this is a project just getting started.
Looks nice.
It uses the 3 arms on the sides to move around the end. And the main principle of it is that you only have 3 motors, but it can move anywhere within a relatively large area, relatively fast, and it remains parallel to the surface. If everything's manufactured with 0 tolerance, but it's generally close enough. So I'm still working on it a lot. It's the control. This finishes booting up. It's Lego, but this is the new UV3, so it's running Linux. It's basically like a Lego Raspberry Pi. And I've made one of these before, but it was really, really rough. It didn't use any kind of math, so it only went to pre-programmed locations, but I have this where it just takes coordinates now. The motor control needs a lot of work. It's really jerky. Now it's zeroing out everything. going to do some basic movements.
It's still technically a flex picker, right?
Flex picker is a type of Delta robot made by ABB Robotics.
Right. Industrial machine.
Flex picker is a brand of Delta.
Oh, okay.
Huh?
Okay. CRS is a brand too.
But there are lots of other people that make them.
Yes.
And now it's just, so right now it's just drawing out a circle, which might be kind of hard to tell because it's going so slow, which, like I said, is something I need to work on. The motor control is not as easy to do as the math that someone already worked out completely. I think it's going to do a larger circle and then something back and forth just to show it stays flat.
I know this is going on in my garage, and I should know this, but ultimately, is the goal similar to the other one for Brick World? Be able to grab pieces, do something with them somewhere else, or just...
For Brick World, yeah. For beyond that, it depends on how accurate it is.
Okay.
Because I don't really know.
Could we take that to 420?
Yeah.
Okay.
Can break down smaller.
Transportation logistics, you know.
So the main problem with the motors is controlling their speeds relative to each other for large distances, because one arm might move a little bit and the other might move a lot. And the stock motor controls don't work out all that well for speed control. So I have to figure out how to do that. And if you have it just move from one point to another, it moves in a curve, so I have to get it plotting a straight line between points and starting and stopping more smoothly. Okay, I guess it's doing another bigger one.
What is the programming environment for it?
Python,
Okay.
for now.
Mm-hmm.
It can use, the operating system basically has system classes that correspond to every motor and sensor port, so you read to those and write, you read and write from those. So basically any program, any language, it can use it essentially any language that you care to, that has file access and that you care to use. But Python is the simplest to set up for it.
Do you have any shaft encoders on the motors?
Any what?
Shaft encoders on the motors?
Yeah.
Relative or absolute?
It has relative encoders, which from the motor can read 360 degrees, can actually read 720 degrees if you modify the firmware.
Mm-hmm.
And then it starts over. And the motors are geared 7-to-1, connected to the arms. The math outputs, the way the math works, it gives you a value for each arm in degrees from 0 starting vertically to up to 360, although that doesn't actually work, obviously. And it does have the ability to determine the range of its limits and throw an error if it's outside. But the math can be applied to essentially any configuration. And if the motors were actually smooth, it seems like it would be really accurate. I don't know if it would be accurate enough for 3D printing, but it would be accurate enough for plotting or drawing stuff. Yeah, that's pretty much all it does for now.